Hello, everyone. And I'm going to continue the discussion on linear regression analysis. And this is the second video. And we were talking about the background to linear regression analysis and what is the objective of linear regression analysis. Now, we discussed that the main objective is to assess the relationship between y and the x variables. So let's take a step back and talk about assessing relationships in itself. And let's talk about some of the ways which you're already familiar with to find out the relationship between variables. So some of these are graphical and the other ones are not graphical. So let's see what are these. So graphical techniques such as scatter plots. So if you have two linear variables, two numeric variables, and you want to find out their relationship, you can create a scatter plot. A scatter plot can tell you that what happens when y increases, does x increase or does x decrease, or what is the strength of the relationship. We will discuss this a little bit as well. And then after that, there is correlation coefficients. So this is something also which you have already, you might be familiar with that. So let's first talk about these two things, ways of assessing the relationship between x and y. And then I'm going to talk about that why do we need regression analysis and what is the main benefit of using regression analysis. So let's first talk about scatter plots. Okay. In this, on this slide, I have a few typical scatter plot relationships that you might find. And let's go through each one of these and discuss, what is the meaning of each of these visualizations. So the first one, as you see, is basically, so this is your y and this is your x on this axis. And this is more or less, positive. This is the positive relationship and it's a strong positive relationship because you see that the data points are nicely linearly aligned. So linearly means that you can explain this with the help of a straight line. Now if you look at this plot here, and this is also a linear relationship, but it is less strong as compared to this positive linear relationship. And how about this one? This is a perfect negative linear relationship. Negative means inverse. So when y increases, then x is basically decreasing. Okay, so that is the relationship that we have for this particular variable. And what about this one? So this one is called a parabolic relationship. Okay, and this is not a linear relationship. Now this is called a curvy linear relationship. You can explain this with the help of a curve. And how about this specific graph? Here you see that there is no relationship. So this is what is known as a random distribution of data. So this is where x and y do not have a relationship at all. So when we were talking about how regression can help to explain the nature and the strength of relationship between x and y, you see that scatter plots can graphically help to do that to a good extent. But sometimes, visualizations might not be that precise, and that's where you need numeric, metrics to measure the relationship. So let's go to the next slide where I'm going to talk about the correlation coefficients. Now, correlation between two continuous numeric variables can be, measured with the help of the correlation coefficient. Okay, this is known as the Pearson's correlation coefficient. Now, you might know this that when the value is 0, it means that there is no relationship between x and y. This is random. And when the value is -1, it means that it's a negative, perfect negative relationship. And the value is +1, it means that there is a positive, perfectly positive relationship. So the Pearson correlation coefficient takes values between -1 and 1, where the closer the value is to 1, the stronger the relationship. And the sign of the correlation tells you whether it's a negative or it's a positive relationship. So this is something that you already know. Now I'm going to talk about why do we need regression. Okay. Now, when does regression come into the play and what is the benefit of using regression? Now, you see that when you have multiple factors that have an impact on y, so your y is the dependent variable, and you have multiple x's, the x variables, and that's what happens in most real world situations. Whenever you have a phenomena that you want to understand, it will often not be the case that there is only one factor that impacts that phenomena. And that is why scatter plots and correlation coefficients fall short in those situations. Because when you are doing a correlation analysis, you can only analyze the relationship of two variables at a time. Whereas in most real world situations, you have more than two variables to be analyzed. And that is where regression becomes very useful. So let's understand why regression helps and how it helps in those situations. Regression provides a mathematical way to find out the simultaneous impact of multiple independent variables on the dependent variable. So I'm saying quite a few things here. So one is that, first of all, it's mathematical. So it will actually give you an equation which is very precise. So when you know the values of the x variables, you plug it into the equation and you get the value of y. So that is very helpful. It's not approximate, it's very precise in that sense. And it tells you the simultaneous impact of multiple variables. This is very important as well, because in real world situations, very often there are multiple factors that impact a phenomena simultaneously, and regression can help you do that. The third thing is that it helps you assess the statistical significance of each relationship. This is a very important point. So, what is the meaning of statistical significance? So essentially, whenever we are working with a data set, we are, let's say, you're working with a sample of, records from a given organization, and you find out that a particular X variable impacts a Y variable. But how do you know if this is statistically significant or not? Or in other words, how do you know that this is a reliable relationship and not a one-off evidence based on a specific sample that you have? So, which will mean that if you go and collect another sample from the population, the relationship might not hold. So, very often, uh, what we really want is we want relationships that are consistent and that are robust. So, in other words, we want statistically significant relationships. So, what happens when you do regression? We set up a lot of different types of relevant statistical tests of significance that tell you that the mathematical relationship that you found out is not happening by chance, and it's rather something which is consistent and significant. So that is something which you can do in your as a part of your regression analysis. Okay, that's another important aspect of regression. So let's continue from here. This slide, I just wanted to show you that what happens if there are outliers in the data, what happens to the correlation statistic. Okay, so a lot of techniques and a lot of metrics, they get impacted by the presence of outliers. And we discussed this that in the very first session, that whenever you have outliers in the data, you have to do the analysis two times, once with the outliers and once without the outliers. So what would happen is that this is a data set, okay, here, and this is also same data set. It's just that you have an outlier here. And the moment you put that outlier in the mix and you could find out what is the Pearson correlation coefficient, it shows up to be very high, 82%, which is pretty high correlation. But in reality, it's only 2%. So which means that if you take out this data point, then the metric changes completely. And that is not a desirable aspect of our results in any analysis, because we don't want our analysis to be very unstable. Okay, or unstable, or in other words, we don't want our analysis to get impacted by a single data point. And that is why we have to watch out for outliers. Okay. And so let's go on. Before I end this video, I want to talk about types of data on which we do analysis, on which we do regression analysis. So we often do analysis on, what is known as pool data. But before I come to the pool data, let's understand what are the different types of data. So there is cross-sectional data and there is time series data. We have discussed this briefly in our EDA class as well. And in cross-sectional data, basically, it's data that is collected at a point in time. So you have annual sales, at a particular location of a product type at a given point in time. And in time series data, you have monthly sales for a retail store, and often time series is represented by line charts. We had discussed that as well. So when we do regression, we often work with something what is known as pool data. Now, pool data is a combination of both cross-sectional and time series data. So in other words, what we're saying is that your regression data can be a combination. So it can have customer profile information collected from a point in time, and it can also have a time series component to it. And that is why this is known as pooled data. So I'm going to end this video here. And in my next video, I will continue with some of the more, advanced concepts of regression.